Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Dear grade 11 students, welcome to this video. This is Mr. Abdurrahman and I wish that you all having a great day. Today, inshallah, will be the launch of this course or this tutorial of explaining the physics grade 11 of the English system. So there is actually a lot to mention, but I'm not gonna waste our time here in the introduction. Um, I just wanted to let you know if you are benefiting from this video and you are looking for more, like you want me to publish the rest of the chapters or do more, let me know, show me your support, and I will inshallah do my best because these videos actually take a lot of effort and energy, but it means nothing if you are benefiting from it. And this is what I wish. So, Bismillah, let's start. Before we jump into the chapter one right away, there is something that I always tell my students, which is the part that this portion of the book is explaining is actually called the mechanics of physics. In physics, there are many fields like of study, the same as like let's say in math you have like trigonometry, geometry, algebra. In physics, we have the same thing. And the thing that we are studying right now is called the mechanics of physics. In mechanics, there are three main topics. Either like it's first one is the motion, then the forces, and then the energy. Force and energy, we have them in chapter 3, forces, and chapter 4, energies. But for motion, it's chapter 1, 2, and chapter 5 also. So this is better to have like this vision before you jump into the chapters. Like you need to know what you are studying basically in physics. This is how you study physics. This is like how you will not be lost when you move on. So with that being said, let's start explaining chapter 1. So chapter 1 is called the one-dimensional motion. Like in this book, we have one-dimensional motion in chapter 1, and in chapter 2, we have the two-dimensional motion, and we will going to understand the difference between them in a moment. But the way that you need to develop the criteria of studying this book of grade 11 and grade 12, because they are the same theme, they are the same format, um, you need always to understand the title of the chapter and the title of each section. Because as you can see here, the title of section 1 of chapter 1 is called Displacement and Velocity. And this is very important. The displacement and velocity is basically the quantities that we use to describe motion. Motion is described by three quantities: displacement, velocity, and acceleration. So the first section here is teaching you about displacement, then velocity, and these the topics that they will teach you those two by displacement, then velocity. And section 2 right away teaching you about acceleration. Now you have all the three quantities that we use to measure the motion. So that's the how we say the understanding of the format of the book when you know like why the book is organized like that. Okay, and after you understood that, I'm letting you know that section 1, half of it is talking about displacement, the other half is sorry, the other half is talking about the velocity. And for section 2, the first half is talking about the acceleration, and the second half is talking about the kinematics equations. And this is gonna be the long portion of the book, of this chapter, at least. Sorry, now we have the third section. This third section actually is not like that crucial, let's say. It's very basic, only two topics: free fall and vertical motion under gravity. Nothing new in here. Everything will be studied in here. The main part of chapter 1 is those two sections. Okay, so starting with the section 1 of chapter 1, the first topic that we have is the motion. So Again, the first thing that you need to have in your mind when you're studying physics is that you need to understand the meaning of the words. So, motion means like an object is moving. So, we all know how to say that in real life, but the way that physics describes motion, let's start with the definition, as the change in position of an object with respect to time. So, anything that you want to move, you are changing its position. That's a fact. But this is called motion basically. And the way that you describe this motion is through these quantities. Yani the way that the physics is describing the motion is by those three quantities. The first quantity is called displacement, then velocity, and then acceleration. It's important to know the order also. And you start with this one, then velocity, then acceleration. Keep that order in your mind. Um, just to give you an idea of like what each one of them means, displacement means like, for example, if you moved an object, displacement tells you how long you have moved it, or like in which direction and how long, how far. Velocity is how much time took you to do this motion, like to do the, let's say, displacement. So if you do it fast, you will take less time. If you do it quick, you will take a long, sorry, if you do it slow, you will take a long time to do that motion. Acceleration is when you change your velocity, and we will understand each one of them step by step. But that was a general idea about them. So, in order to study those quantities in physics, we need something called the frame of reference. The frame of reference is okay, let's start with the definition. The book is telling you it's a coordinate system for specifying the precise location of objects in space. This may not give a very meaningful like ideas maybe, but I have a better way of describing it. First thing, let's start with this word. It's looking like a long word, right? You may see it. A lot of students like think coordinate means something complicated, while it's not. I can explain it through our daily life. If you, for example, you are using, let's say, Google Maps, and you want to go to somewhere, let's say a restaurant, or like we are living in Erbil, so let's say that you want to go to Grand Majdi Mall, for example. You will locate this place on the map. It's on located on the way of Masif. This is basically the coordination of it. And when you say that this place is located here, you are taking the coordination of it. So the coordination system that you are using to locate things, the map in that case, is called the frame of reference. It's a coordination system. To give you a better idea about it, let's see this picture here. We can see that this car is moving to the left. The car for us from our perspective is moving to the left. So as you can see here, there is two people looking at this car moving. This person here, this man, is saying that this car is traveling to the right. And for him, it's correct because he's standing here and this is his right hand and the car is moving to that direction. So from his reference, from his perspective, the car is moving to the right. But for the perspective of this woman, the car is traveling to the left. So both of them are correct from their frame of reference or from their perspective. So this is why we say that we need a frame of reference. Okay, that was the first part. Then, when we understand the frame of reference and we understand what we are going to study, now we will go to the actual, let's say, steps of studying. So the first thing that we need to keep in mind is that we are studying the one-dimensional motion in here, in this chapter, at least chapter one. The one-dimensional motion is the most basic type of motion. There is more types that are more complicated. This is the easiest one because it's only a motion of either forward or backward. You are either moving forward or backward on a axis. What do I mean? Let's see what do I mean here. So This is like only the one-dimensional motion. I wrote only motion. So the motion is the one-dimensional one. Sorry, I did it down. So motion is divided into two, one-dimensional and two-dimensional, but let's first understand the one-dimensional one. The one-dimensional, as we said, it's either forward or backward. But this forward and backward could be happening in two ways, either horizontally on the x-axis, the object is moving on the x-axis either to the right, which is east geographically, to the east, or to the west, which is to the left. Normally, the right is positive and left is negative. Or the object is moving vertically, which is upward and downward, north and south, also positive and negative. This is the one-dimensional motion, basically. The two-dimensional motion, the one that we are going to study in chapter 2, is a motion that is mixed between those two. Yani the object is both moving to the horizontal direction and to the vertical. As you can see here, this person is doing something that is not good, which is throwing a projectile from a cannon. And this projectile is moving to the east and it also went up at the beginning. So that's a mixed motion, both upward and to the east. So two-dimensional. Now, starting with the first quantity of motion, which is displacement, the displacement is, and this is very important, those three words are very, let's say, essential. The three words which are the smallest directional distance. You need to keep them in your mind. So I would highly suggest you repeat them again and again till you sleep today. So say it with me again. Smallest directional distance. Each one of them, of these words, is actually meaningful. So keep it in your mind. So I will say it one more time. Smallest directional distance between 2 points. One of them is the initial point, which is the starting point or the starting position, and the other one is called the final x, like final position or the ending point or whatever you want to describe it. I'm going to show you anyway, so you will keep it in your mind. But one of them is called x initial, initial position, x final, which is final position. Let's look at here. Let's say that this is you. You decided to go on a walk today. You started from your home, and let's say that you are moving to a park. Let's say Park Sami or somewhere, anywhere. The normal thing that will happen in life is that your route will not be a direct path. Like you will always have twists and turns along the way. I'm saying always is not correct. You may have a straight path, but let's say more often this will happen that you will take twist, you have to go somewhere because of the road. So you can see that this way is long, right? It's not a straight line, so it's not these three words. It's not the first one, at least. You started from the initial place, which is that place, and you are heading to that place, which is the x final, which is the final position, and this was the initial position. What's between them, the route that you took, we cannot call it displacement because displacement will be only a straight path from here to here, a line between those two. So here it's only called distance. It's not displacement. Displacement is more like this, a straight line between 2 points. The same thing here. We have x initial and x final, and the displacement is just a line between them. So pay attention to delta x. Delta x is displacement. D is distance. Distance, displacement. Okay. So with that being said, we understood that displacement is the smallest directional distance. You see here, that's an arrow, so it has a direction, and it's the smallest possible one. Moving on, the way that we measure displacement by is throughout this formula, which is basically any delta in physics is measuring the change. So here we are studying the change of displacement, which is the starting sorry, the final position minus the initial position. This is the terminology of how to use it. Delta is representing the change, so anything written beside delta will be the final value minus the initial value. We are using x because that's a horizontal motion. The displacement is measured by meters. So that's something that is obvious in physics. You already took it in grade 11, sorry, grade 10, chapter 1, that you studied that each quantity has its unit. So the standard unit to measure displacement and distance is the meters. So that means if the question is giving you uh, the displacement by kilometers or millimeters, centimeters, you have to convert them to meters, then use them. We will study this later on, but like just letting you know. So displacement, as we said, can be either horizontal or vertical, but like if it's horizontal, we represent it by the delta x. The symbol is delta x for it. But if it's a vertical motion, we represent it by the delta y, which is the y-axis basically. So you can see here the object is moving up. So we use delta y to describe it, while here we use delta x. Okay. Now that's a that's actually the important part of displacement, which is displacement is a what's that word? Read it by yourself. It's a vector quantity. Yes, correct. This may remind you of something you studied in grade 10 maybe, but vector quantities are something essential in physics. Yeah, you cannot study physics if you don't know what is a vector quantity and what is a scalar quantity. Vector quantity is a quantity that has both magnitude and direction. Magnitude means the value of it, the number. Like let's say 5 meters. 5 meters is the magnitude. Direction is where you go. If I tell you to go 5 meters to the right, that's your displacement. But if I'm saying only 5 meters, that's only distance because I did not specify the direction. Distance is a scalar value. Displacement is a vector value, vector quantity. I wish that makes sense. By the way, we represent the direction. So as we said, magnitude is the number. Both scalar and vector quantities have the magnitude. But the thing that the scalar quantities does not have is the direction, right? So the direction of the vector quantities is represented by the sign. The sign which is either positive or negative. So if it's a positive, it means it's moving either to the east or to the north. If we are talking horizontally, it's the east only, east or right. I tell you delta x is equal positive 5, you will know that this motion is to the right. If I tell you negative 5, you will say to the left. If I tell you delta y is equal to negative 5, you may say to me it's going down, and that's correct. If you say delta y positive 5, that's up north. Okay? I wish that makes sense. So now this part is actually tricky and important at the same time because we normally don't explain it in the lectures, but we bring it in the exams. The reason for that, it's a tricky part. Um, the trickiness of it is coming from the formula. You look at the formula here, you see that delta x is equal x final minus x initial. This case that we are talking about in here, let's see this person to understand it. This person is starting at point A, moving all the way around, and then coming back to his starting point. So in that case, the starting point or the starting position, the x initial, is the same as the final position, which is the x final. He basically returned back where he started. So in that case, both of them are equal to each other, which makes delta x equal to 0. That's the idea behind it. It may be phrased differently in the exam, but you need to relate it to that case. Okay. So now we have understood the displacement, um, and we understood the distance also, but to give it a definition, the distance is the length of the total path of the motion, or the total length of the path, while the displacement was the smallest directional distance. So that's actually telling us the difference between them. And this is another example. If you are starting, let's say, from one of these homes, let's say you started from here, you are moving to that home, your displacement is gonna just be like you started from here, you ended at here. This is what displacement cares about: where you started and where you ended, and just draw a direction, a line between them, a straight line. But distance, sorry, worries about the whole path that you took. How long was it? So if it's 20, you are moving this 20 meters, but this will be for sure either equal or less. In that case, it's less. So let's say 10 meters. Okay. Now let's move on to, okay, this question. This is a question from the chapter review of chapter 1, and it's easy to a degree where I will not answer it. Now I will give you a moment to think about it, read it, pause the video, and try to answer it by yourself. If it's possible, write down your answer and see if it's correct or not. Okay, I will give you 3 seconds. 2, 3, that's done. Okay, so the way that I answered it, the question is telling you answer in 1 or 2 sentences, explain the difference between displacement and distance. So I did that. We already answered that. We said distance is a scalar value which has only a magnitude, and this magnitude, a number, is always positive if it's a distance. But for displacement, um, it's a vector quantity, which means it have both magnitude and direction. The magnitude, which is like both of them have, is just the number. For example, 5 meters. But displacement worries about the sign of that number, if it's a positive 5 or negative 5. If it's a positive 5, it means either to the right or upward. If it's a negative 5, either left or down. So that's the main difference here. And then this is important, this like symbol is important for the exam. Yani, it could be a tricky like multiple choice or something, as I always bring in the exams. So either, okay, the displacement is either equal or smaller to the distance. Okay, so we use this symbol to it. The distance is always either equal or greater. Okay, as we saw in this example, I have, I think, yes, this example. If we start from point A moving to point C, this kid has two possible paths. Okay, the first one is going to that home, then to the tree, which is like 4 plus 3 meters, which is 7 meters. So that path is longer, while he have another path which is shorter, which is only 5 meters. If he took that path, that will be the displacement and distance. Both of them are equal to each other. If he went through this path, the displacement will be 5 meters because he started here and he ended here, okay? 5 meters only. But the distance will be 7 meters, the distance that he took. So the distance is higher than displacement. But if he took that route, both of them are equal to each other. I wish that makes sense. So now, how to use the displacement? As we said, it should be always in meters. So if the question is giving you displacement by something else, not meters, you have to change it to meters. If it's giving you by the way, those orange words are called prefixes. Prefix is things that we use to either scale up or scale down the unit. Okay. So kilometers, which is the first one that you see, is basically, sorry, it means that you have 1,000 meters. So if it's 1 kilometer, it's 1,000 meters. If it's 3 kilometers, it's a thousand kilometers. So the thing that you used to change from bigger units to smaller ones, in that case, we multiply by the value, which is multiplying by 1,000. If you are changing from a small unit to a bigger one, you have to divide by the ratio. This number is called the ratio, though, dividing or multiplying by the power of negative. So as you can see here, we are multiplying by 10 to the power of positive 3. So the operation here is multiplication. We are multiplying by this ratio, while here we are dividing by this ratio, which means, let's say, 500 centimeters. If we divide it by 100, it will be 5 meters, right? The same thing if we multiply it by 10 to the power of negative 2. I wish that makes sense. And millimeters is 10 to the power of negative 3. This is 100, this is 1,000, and that's it. That's the meaning. Not just like, I just put it because it was a nice picture. Start and end. Smallest directional distance is displacement. The longer one is distance. And we are done. Now going to the second quantity, which is velocity. Velocity is basically depending on displacement. And if you have any things left in displacement you did not understand, you must go back to it. You must fix it now, okay? If you have it perfectly done, then stick with me to understand velocity. So velocity is the rate of change of displacement per the change of time. So it means how fast you will change or you will do the displacement basically. Let's see a picture to understand that. We are seeing that this car is moving from that place to that place. So if we start measuring how fast the car will move from here to here, which means how much time will it take this car to move from that position to that position. This is, let's say, the initial position x initial, and that's the final position x final. So in order to measure delta x, we will say delta x is the x final minus x initial, let's say 10 meters. So what we do, we tell this guy who's driving this car, yalla, go ahead, and he drive on. And what we do, we start the timer. The timer here is how much? Time is 0. So we start counting how much time it took him to move on from that place to that place, and the final time will be how much time he needed to finish this motion. So if it's 10 meters, let's say he took in the car, let's say he took like 2 seconds, which means 5 meters per second. I know it's like fast, but logical. Okay, I wish that makes sense. So now, coming to the formula of velocity. For the formula of velocity, we use this formula, which is V average is equal to delta x divided by delta t, which is the displacement divided by time, which is described by the definition, rate of change of displacement per the change of time. As we said, each delta means change. So this formula is described by this definition. Yani both of them are related. When you see word per, it means division. So delta x is measured by meters, and this is basically the standard units. Time is measured by seconds. So if it's given to you by minutes or hours, you have to change it to seconds, then use it in the formula. And then the unit of velocity will be meters divided by second, which is called meter per second. You can open each delta like that. X final is the final position. As you can see, delta x final minus x initial, delta t, t final minus t initial. The unit of velocity is meters per second. You can write it like this or like this, both are the same. So now velocity is also a vector quantity, which means it also has magnitude and direction, and the same thing is represented by a sign. Velocity and displacement are exactly the same direction. Yani they are always the same. Whenever you tell me that the displacement is going to that direction, velocity is with it always. But acceleration, which is in section 2, may not. Okay, keep that in mind. But for now, keep write this as a note if you didn't. Velocity and acceleration are always in the same direction. Okay, let me show you that. So as we said, its direction is represented by a sign, so it's either positive or negative. How we know if it's positive or negative? We see in the question if it's mentioned these words: north or east, positive; south and west, negative; up and right, down and left. Okay, keep that in your mind. So as I said to you, the note that you should be right, that you should have wrote already, which is the both velocity and displacement always have the same sign. If one of them is negative, the other one is negative, positive, positive. The benefit of that is to make the delta t always positive, which means time is always positive. Time is a scalar quantity also, which means it's always positive. Yani time is always moving forward. It's impossible to make time move backward, right? Someone may debate this, but I will not answer it. But no, seriously, guys, when you put these signs in the formula, you, I would recommend you trying this, by the way. You will always eventually get delta t equal to positive. This is how the formula works. Okay, so converting the given units in the standard. As I said to you, there is like a standard unit for each quantity. What do I mean by a standard unit? Is the unit that you should use. So if they give you another units, you have to convert it to the standard, then use it in the formula. Okay. So starting with the first quantity delta x, the delta x has many possible units. Let's see them. Kilometer to meter, that's the most, let's say, common one that comes in the questions, which is they give you kilometer, you have to change it to meter. You multiply by 1,000, which is 10 to the power of 3. But sometimes they give you a quantity which is smaller than meters. In that case, you have to multiply by a negative power depending on the unit given. In this case, they gave you centimeters, which you have to divide by 100. Dividing is the same as multiplying by 10 to the power of negative 2. The same thing here, but this time millimeters, which is 1,000 times less than meters, and micro is a million times smaller than meters. So this is for displacement. There is actually more. There is nano, there is like mega, giga, but like these are the common ones that I mentioned here. For time, it's one of those two normally, minutes or hours. If it's minutes, you multiply a minute by 60 to get seconds. It's basically telling you that each minute have 60 seconds, and each hour have 60 minutes, and each minute have 60 seconds. So you are multiplying 2 times by 60, and this will give you 3,600. For the velocity, um, there is a case that is common, but it's a bit tricky, and it's not that tricky. It's a bit tricky, but you need to understand it for sure. It's like 1,000% coming in the exams, which is they will give you the velocity in the unit of kilometers per hour, which is the unit that we use daily in the cars, for example. So this unit, we don't use it in the questions when we solve. We need to change it to the standard one, which is the meters per second. The way to change it here is actually we need to change two units, kilometer to meter and hours to seconds. And doing that in a fraction, and this is a fraction basically, the kilometer in the nominator, which is the upper side of the fraction, and the time, which is hours, in the denominator, which is the lower side of the fraction. So we need to multiply by a fraction. We are changing from big to small, so we are multiplying by this ratio. Kilometer to meter multiplying by 1,000, and hours to seconds, as we saw here, multiplying by 3,600. So we multiply by this ratio. keep that in your mind. You have to memorize this ratio. There is a better ways of writing it. You can write it like, for example, 3.6, and like there's many ways of writing it, but I recommend keep it on this form. It's better to like memorize it, and it's like more giving you the idea behind it. Sometimes they may give you only one of the sides of the fraction that you need to change. The other one is standard, which is seconds, right? You only need to change kilometer to meter, so you just do the same that we did here, multiplying by 1,000. But um, this did not come in the book that we have, but this one is in the section review. I think question one in the section review 1-1. As you can see here, you are just changing millimeters to meters because second is already set. You don't need to change it. So you just multiply by 10 to the power of negative 3, or you divide by 1,000. Now, a lot of students, and this is a very common question that we get as like physics teachers or even math teachers sometimes, they get the same thing, which is after explaining the subject, after understanding it, we need to know how to use this knowledge that we have. So this is the part where I show you how it's possible to bring a question. So first thing before I go to that, the formula that we will use is V equal to delta x over delta t. A lot of students ask me first, like, where is the average part? Why did not you write the average? Look, if the question is mentioning only one value for velocity, that's the average value. You don't need to bring something else, okay? So starting with the units, we already discussed that part, and then the average velocity is equal to velocity, so that you don't ask me again. Now, the first case that is possible to come, before we go to that case, the case that I'm going to take, let's say that someone is moving 10 meters. This is the displacement, 10 meters, and he need, let's say, 5 seconds to cut the 10 meters. So that means his velocity is 2 meters per second. So this is the all the quantities that we have. Okay, which is the three quantities. This formula have only three quantities: velocity, displacement, and time. So the question always, all the times, will only ask you for one of them. For example, by the way, like I don't mean in other formulas, but like only this formula, always we are looking to find one of them. So if the question asking you to find velocity, it must give you the displacement and the time, which is delta x and delta t, asking you for velocity. If that's the case, you will use the formula in the same standard way. You will not change anything. You just need to substitute the numbers that you have given in the question. By the way, it has to be in the standard units. If it's not, convert it, then put it. In that case, it's already standard, so we will just substitute them to find the velocity. Second case possible is to give you the displacement with the velocity, asking you for the delta t. Here you need to modify this formula. You need to derive the delta t. This is called driving, taking the delta t out, making it alone equal to something. Let's see how we can do that. First thing, we take the standard formula and we change it. How we change it? We do something in here called cross multiplication, because we can see that this is like a fraction, and this is also a fraction because it's velocity over 1. If it's nothing written here, it means over 1. So when you see equal sign between two fractions, you can do a cross multiplication. How you do it? You take the numerator of that side, multiply it by the denominator of that side, and the same thing here, numerator by denominator. This will give you v multiplied by delta t, delta x multiplied by 1, which is only delta x. So now you can see that here we need to find delta t, right? So we need delta t to be alone. You can see that here delta t is multiplied by velocity. So how to get rid of this velocity is by doing the opposite operation, which is the opposite of multiplication is division. So we need to divide the velocity, um, we need to divide both sides by the velocity. So this side divided by velocity will be cancelled, and here delta x divided by velocity, as you can see here. Okay, so then it's now set. You just take the values and you substitute them in here, and you will find your answer. The last case, the most, I will not say common, but like it comes a lot, when they give us the velocity and the time, asking us for the delta x, which is the displacement. You take the formula again, you do the same thing, cross multiplication. But as you can see in here, after doing the cross multiplication, you can see that delta x now is alone. It's alone and equal sign. So the formula is already set. But we will just bring it to that side to do the same. When it's equal sign, you can't change sides. Nothing will change. And in here, nothing is written. It means multiplication. So we take the numbers, we multiply them, and we will have the answer back. So that was all the cases possible. I wish that you understood them. If you have any questions, let me know. Coming to the sample and the practices, I will make them in a separate video to not make this video too long, but let's do one of them here. We have the velocity given in here, and we have the delta t, the time. So obviously it's asking us for displacement. We did that already. We just substitute the numbers. Because we need delta x, that's the third case, the one that we took earlier. That's the third case. So the formula is like that. You just substitute the numbers that are given to you, and you will have the delta x value. Okay. I will not solve the rest because it will take time. It will be in a separate video, and you will see them in the Malzeme or the guidebook. So now coming to a very important part actually. This part is crucial to understand. يعني it's not necessarily like, let's say, fundamental, but it's important to keep in mind because like it's telling you how physics is working. Um, we will study here how to represent velocity in physics using physics. So the way to represent velocity in physics is by graphing it. Graph how it's like changing. So in the graph, which is the way of representing velocity, the velocity is the slope of the line. Which line? Let's look on this graph to understand it. As you can see here in this graph, we have two axes. This axis is the x-axis, which is representing the change of time. And this axis, which is the y-axis, is representing the change of displacement. You may see x here. This x means the horizontal displacement. This is why it's delta x. But it's located on the y-axis. So, as we said, the velocity is the slope of this line. As you may know from like previous years that when you studied the slope of a line is measured by the rise over run, which is the change on the y-axis over the change of x-axis. In the formula of velocity, the y-axis is representing the change of displacement. Y, change of displacement. X is change of time. So you can find the slope using this formula. This is why we call it slope of line. So now there is, with that being said, actually, there is three possible cases for the graphs of velocity. The first possible case is the graph or the line will be constant like this, and it will be straight. In that case, it means that your position is not changing when the time is changing. You start counting time here, your position, let's say, was 5 meters, and you stayed when the time ended, your final position was also 5 meters. So it means that you did not move, which means your velocity was zero. So your initial position was the same as the final position. So when you put them in the formula, you will have delta x zero. When you have delta x zero divided by anything will be zero again. So that gives you velocity zero. In that case, the slope is positive because the line is moving up. When we move from left to right, the slope is rising. So that's a positive slope, which means a positive velocity because the x final is greater than x initial. And that's why here it's negative because x initial is greater than x final, which gives you a negative velocity. Now comes to the important part. The important part, why? Because it's explaining for you why we are writing the average in the main formula, the average velocity. And the average velocity is the total displacement divided by the total time interval. The reason why I'm saying total, like what does total means? It means if you have, like, let's say if you walked a distance, let's say that you went from your home and you walked, let's say, to Park Shami, and then from Park Shami you went to your work, let's say, which is in let's say in Shoresh. So there is two distances in here. There is distance one from your home to the park, and then from to the park to your work, which is x1 and x2, and each one of them has its own specific time, so different velocities. So if you are looking to find the average velocity that you took, you will add them, which means you will sum them. This sign represents the summation of the addition of two displacements and the summation of two times. So this is the average, okay? But the instantaneous velocity, this is the interesting part. The instantaneous velocity is the velocity of an object at some instant or specific interval. Coming back to our example, if you moved from your home to the park, and then from the park to the home, sorry, to the work, there is two different velocities. Each one of them is called the instantaneous velocity. We call them V1 and V2. Let's see an example. They need to be different, by the way. If they are constant, which means like you have a constant velocity, it means your velocity is not changing. The slope of the line is exactly the same. So this will always give a constant velocity. The velocity value is not changing. So in that case, both average and instantaneous is the same. But in the case where you have a non-constant velocity, which means two different velocities, like in this graph, let's say that if we took this point and that point, the slope between them will be like this. So this slope is representing the first velocity, which is the first instantaneous velocity. We call it v1, let's say. And the other one, from this point to that point, from that time to that time, you cut a higher displacement, a higher position in a shorter time. So your velocity here, v2, is bigger than or higher than v1. But if you want to find your average velocity, there is two possible ways. First way is to add those values if you have them, divide them by 2. But if you don't have them, you will sum the position, which is delta x. For example, v1 has delta x1 from here to here. v2 have delta x2 from here to there. That's the delta x2. You add them. You say delta x, the total or summation of delta x is equal delta x1 plus delta x2, and you will have the total. The same thing for the time. Delta t1 from here to here and delta t from here to there. And the same thing, you will have the final. So till here we have done with the topics of section 1 of chapter 1. I will do the questions separately, the questions of this section. So I wish that you all got benefited from this video. If you do so, please let me know. And if you have any question, feel free to ask it, and I will do my best to answer it, inshallah. I wish you all a great day, and I wish you all success throughout your journey. If you are If you are interested to see more episodes of this tutorial, um, let me know, show me your support, and this will push me to do more. With that being said, in the end, we say سبحانك اللهم وبحمدك لا إله إلا أنت أستغفرك وأتوب إليك. Have a nice day.